I wanted to talk a little bit about what we're currently working on to bring even more value to our customers using AI. And in the interest of time, I will only talk about the first one of them. And this is something that was mentioned before. This is this closed loop remediation, where we allow the AI to take action automatically without a human in the loop and deliver the value autonomously. Let me explain it in the example of this indoor RF optimization. This is the one that Shri was talking about earlier, where Wi-Fi networks are sometimes hampered by passerby clients that walk by a building, and the Wi-Fi coverage inside the building leaks outside the building. These passerby users will connect to it, especially when the network is an open network. And that leads to a lot of short-lived connections on the access points. It's a lose-lose situation because the passerbys are not getting good experience. They have weak signal. They will not have a strong enough link, actually. But at the same time, they're worsening the experience for the legitimate indoor users. So we solved this, as Shri was explaining in the earlier session and showed you in the UI. We solved this by a machine learning classifier that can separate the undesired outdoor users from the legitimate desired indoor users. And we further built this out into a closed loop remediation that can set the optimal configuration automatically on the access points and have them mimic the classifier output. And I'll explain exactly what that means on the next slide. The result is that the settings are automatically applied, the indoor users receive a performance boost, and nobody ever had to go on site to actually make that change. It's all automatically controlled from the cloud. Here's a picture that in a similar version you had seen earlier on the actual central web interface. This allows me to explain how the classifier works. The classifier sits on the cloud, and for every moment in time, for every client it connects to the network, it can decide whether that client is currently inside a building or outside a building. It does this by looking at various input features, such as the signal strength at the access point that it's connected to, the signal strength at the other APs that over here that it's not talking to, but they can still perceive that client, the change of the signal strength, the site of the size, the type of APs, all of these features go into the classifier. The classifier itself is trained on a golden data set that we have labeled by collecting data in actual physical locations that took a representative sample of our customer space. The classifier is trained, and then it runs in the cloud at every instant of time to decide whether the client is indoor or outdoor. The access points themselves that are on-premise, they are not able to run this model, but what they can do is they have a configuration knob that allows us to set a threshold of a certain signal-to-noise ratio below which it should not accept new clients. And so a config optimizer then connects these two pieces. It takes the classifier data from the cloud and determines the optimal setting on the access point so that the access point can mimic this classifier behavior. The access point is trying to reject the outdoor users. It cannot run the full classifier, but it will just simply do a cutoff at a certain SNR, and we choose this cutoff so that the majority of the outdoor users falls below and the indoor users fall in the vast majority above it. And then here's how everything fits together. The raw data comes in from the access points. The classifier will determine whether the location is indoor or outdoor. The optimizer will determine how to map that classifier output to a config setting that the access point can understand and implement on-premise in the site of the customer. And this setting now can either be applied manually or automatically. If the customer has a choice to either review this recommendation and have their own opinion to decide whether that's something they want to go ahead with, or they can set this particular configuration to be AI-driven, in which case the algorithm will push the setting to the access points and apply it directly. It does this at exactly the right granularity. And by that, I mean, it has separate optimizations for each SSID, for each network that's actually configured, because customers may want their IoT network to behave differently than, let's say, a guest network. You can be more aggressive on a guest network. And the AI is also able to choose the right granularity at the AP level. It can choose a subset of access points to apply aggressive settings to, because those are the ones that are at the perimeter of the building and therefore receiving most of the passerbys, and not apply an aggressive settings to the AP that are in the interior of the building and not even contributing to this problem. So this is how we close the loop. This concept I've explained here for the particular example of the rejecting the passerby users, but of course the concept applies to many other insights that we've built as well. And the closed loop concept here actually allows us to do more interesting things algorithmically as well. For example, if you have a closed loop, you can apply settings on a much faster cadence, and you can reach the optimal setting in a sequence of many small steps rather than having to estimate a perfectly calibrated single step change, as you would have to do if you are telling a person to make the change. And so having this closed loop actually allows the requirements for the config optimizer to be a little lower, and it allows us to do more cases in a config optimization sense, because now the config optimizer only has to determine a confident estimate of the direction to move to, and then it can make a small change in that direction, see if it's working, and if yes, go further in that direction. And so we don't have to estimate the perfect setting in one shot. This, by the way, also allows us to do active learning, where we temporarily change the objective function from the highest benefit to the customer to actually the highest visibility. So for example, we can turn the settings to be very loose to see even what all is there, what activity would be there if we were accepting everything into the network, give us a full picture of the view, and then again go to optimization mode and maximize the benefit of the customer. That switching between maximum visibility and maximum benefit can be done on a fast cadence. It can be done for a subset of the network in the sense of an A/B testing, for example, and it allows us just to be much more agile when we optimize the network and move it towards a self-driving mode.